In this lecture, we will take a look at the airport system and what role it plays in the field of air transportation or civil aviation. Because I am calling it a system, it is important first to understand what is meant by a system. How do you define something as a system? A system is basically a group of things or parts that work together in order to achieve a specific goal. Now, is airport a system? Definitely yes, because there are many elements in the airport that are going to work together to achieve the specific goal of allowing safe and expeditious flow of air traffic, both arriving and departing. So, the goal of an airport system is safe operation of aircraft to transport passengers and or the cargo. There are two main subsystems of the airport system. There is an airside area and the landside area. So, airside area is the area where the aircraft are normally physically located. It starts from the apron or the gate, and then it includes the taxiing way system, the holding area, and of course the runway. This is the airport component where the aircraft operate, also called as the airfield system. Then you have the landside area. This is actually where the passengers are mostly located before they board the aircraft. Okay. So, this is where the passenger and the cargo operate, also called as the passenger terminal. It consists of parking, it consists of terminal building and all the shops and the facilities nearby. Here is an example of Dubai airport. In Dubai airport, it is a linear airport, so it is very easy. You just draw this line and all items on the left of this line represent the airside area and all items on the right of this line represents the landside area. Okay. But the same may not be so simple and straightforward at all airports. Landside and airside areas, they may not be clearly demarked as shown here. For example, here is the layout of the Chhatrapati Shivaji International Airport in Mumbai. Now, here you can see that these are the two landside areas. The areas below the red line on the left hand side and the area on the right of the red lines on the right hand side. That is the landside area. Terminal 2 is here and Terminal 1 is here. And in between you have this cross runway in Mumbai and you have all the other area is the airside area till the boundary of the airport. Now, what is the layout of CSIA airport? You have these piers, okay, and there are all these gates where the passengers can walk and connect to the aircraft. There are many factors that affect the sizing of the airside area. For example, the number of runways, the number of taxiways and the aprons that you require. What are the lengths and the width of the runway? What are the runway orientations and taxiways? Are they all parallel or are they inclined? If they are parallel, they will generally require lesser amount of land area or lesser size. But if you have cross runways or multiple runways, then you will need larger area. Pavement type and thickness, and also the location of the terminal building. If the building is on one side, you will require more area. If the building is in the center of the runways, you require lesser area. Now, what is the aim of airfield design? Efficiency in operations is the primary aim, and then flexibility, ability to handle changes. There should be potential for future growth. It should not be that you design the airfield today to meet today's requirements and then there is no room for expansion. You have to adhere to standards and recommended practices when you design the airfield. The question arises, why you require these standards? Okay. They are required primarily for operational safety, okay, and also for some uniformity, so that you find very similar layouts where you travel to other airports. There are standards for airfield design which have been prescribed by the regulatory bodies. For example, the Federal Aviation Administration, which has given the airfield design guidelines, these are applicable for airports in the USA, and some other countries have also adopted or accepted the FAA guidelines as being applicable to their own country also. Then you have the ICAO guidelines. These are meant for international airports. ICAO, as you know, stands for the International Civil Aviation Organization, right? Both of them, they use similar but not the same coding systems. They code the aircraft, okay? The aircraft is classified based on the most demanding type of aircraft designed to serve, and once the aerodrome reference code is specified, design standards are obtained from relevant manuals. Okay. Every country adopts either FAA or ICAO guidelines. In India, we have adopted to ICAO guidelines. So, based on whether you follow FAA or you follow ICAO, there are various classification codes. If you follow FAA guidelines, then approach speed of the aircraft or the speed at which the aircraft approaches while landing, generally it is 30% higher than the stalling speed of the aircraft at maximum landing weight and landing configuration with the flaps and the landing gear at the appropriate configuration. This is one parameter, the airspeed during this particular condition, and the other parameter is the wingspan of the aircraft, that is the distance between the two wing tips. If you go to ICAO, they do not use approach speed and wingspan directly. ICAO uses what is called as reference field length or RFL. This is the runway length required for safe operation of the aircraft at these conditions, at max takeoff weight condition, sea level ISA conditions, assuming no wind and assuming the runway to be perfectly level. So, whatever is the runway length required for safe operation under these conditions, that is called as the RFL or the reference field length. ICAO uses RFL as one of the parameters for airport classification, and the other one, instead of wingspan, they use outer main gear span or distance between the outermost wheels of the main landing gear is called as BOMG. Now, let us see how ICAO does. So, as I said, RFL is the minimum field length required for takeoff at the rate or at maximum takeoff weight, ISA, sea level, still air and zero runway slope. So, there are 4 code numbers defined by ICAO. If the reference field length is less than 800 meters, then your runway belongs to code number 1. If it is between 800 and 1200, it is code 2. If it is more than 1200 but less than 1800, it is code 3, and anything which is more than 1800 is called as code 4. And for the wingspan, there is a letter. So, depending on either the wingspan or the outer main gear span, whichever is more critical, you have to assign a code letter to the aerodrome from A to F. So, the largest aircraft which have high wingspans and also larger distance between the outermost gear, they will be classified as F, and then below that will be E, and then D, and then C, and then B, and the smallest will be A. For the smallest aircraft, the wingspan is less than 15 meters and the outer main landing gear span is less than 4.5 meters. FAA, as I said, uses approach speed, and there they have used A, B, C, D, E category depending on the approach speed. How many knots is the approach speed? If it is more than 166 knots, it is considered to be E, and then you keep reducing it. Approach speed less than 91 knots, those aircrafts are the smallest aircraft, they require the least runway and they are under category A. And the wingspan is used for airplane design group from 1 to 6. So, any aircraft which has got a wingspan up to 60 meters, but more than 65 meters comes under airplane design group C. So, the airport that it needs will be minimum design group 6. Now, let us look at some popular aircraft and in which category they belong. So, if you look at Boeing 717, this falls under FAA Aerodrome Code 2 or ICAO code letter B. If you look at the entire A320 family, A318, 319, 320, 321, the entire Boeing 737 family, 600, 700, 800, 900 and also the MD-81. All these aircraft fall under Aerodrome category 3 under IFAO or code letter C under ICAO. Then you have mid-range or longer range aircraft like A310, A300, 757, 767 and MD-11. They come under code letter D or ADC or Aerodrome Design Code 4. And then you have aircraft like A330, A340, Boeing 747 and Boeing B777, very large aircraft. In Boeing 777, they have gone for folded wing tips to ensure that the aircraft remains within code letter E. And finally, we have code letter F currently or the FAA ADC 6. Currently, the only aircraft in this category is the Airbus A380 and maybe also AN 225 and AN 125. They would also fall probably in this last category. Now, let us look at the layout of an airport designed for large aircraft such as the Hong Kong International Airport. Here you will notice that the structure of the terminal is such that you have spaces for accommodating large aircraft, and here you will have more proportion of aircraft in category 5 and 6 and there will be less aircraft in category 1 and 2. And see, this particular place is for Airbus A380 because you require a larger bay. So, one is here, the next is only here. This is discontinued because it allows Airbus A380 to come and park here. Here is an airport which is designed for small aircraft. This is the Phoenix Airport in Arizona. In the Phoenix Airport, you will find that you have a structure like this, where all these small aircraft are going to attach themselves like a pie on the finger. Here, the proportion of the aircraft categorized in category 3 and 4 will be much higher and those in category 5 and 6 will be much lower. And in category 1 and 2 also will be much lower because those are general aviation aircraft, small aircraft. Like any organic organism, airports also evolve over time. Okay? They don't remain static. One of the most common things in the evolution of the airports is the addition of runways. Mostly they are parallel to the existing runways. Okay? But you can also look at an airport which have got many runways and then you remove some of the unwanted runways. Over a period of time you realize that they are not needed. This is very much true for airports which have multiple runways in different orientations. Another way in which the airports could evolve is to lengthen the existing runways, provided there is space available at the end of the runways. Okay. Then in some airports, we evolve the airport by expanding the existing passenger terminal buildings. So, you have one terminal in the beginning and then you have one more terminal. This happened in, for example, the Kempegowda Airport in Bengaluru. You could also introduce new passenger terminal buildings. When we look at the planning of airports, we realize that sometimes because of improper planning or short-term thinking, there are many inefficient airport layouts. What are the factors or features of poor planning? Too many runway intersections. This is compromising the safety and reduces the capacity, because every time an aircraft has to cross an active runway, they have to stop and take clearance from the ATC. Similarly, when there are many intersections and if the aircrafts are coming, then the aircraft on the ground which are taxiing, they have to wait till the runway is clear. This leads to the reduction in the operating capacity. Then there are examples of suboptimal passenger building layouts. Okay. So here the terminal is so far away or in one corner that the taxiing time required by aircraft to reach the terminal or to go from terminal to the beginning of the runway is very large. And in many cases we find that the connectivity between terminal buildings is very poor, and it may take a lot of time for people to either walk through or even travel by other modes. So let us see how some airports have evolved. So this is the map of London Heathrow, one of the world's busiest airport in 1952. You will notice there are so many runways which were active, but then you will see now very slowly that these runways on the green were active and the one on the top were proposed in the future. Okay. This was the scenario of London Heathrow Airport in 1952. Now, what actually happened? In 1980, it was found that only the runways which were green in color, they were remaining, and two of them were lengthened. And the one in the purple color which were used earlier, they have now become only taxiways. They are no longer in use. If you look at London Heathrow in 1990, you will see that it consists mainly of parallel runways and one little bit far away and two in the same vicinity. This is the London Heathrow Airport today. We have only 3 runways, 2 of them are parallel and one of them is a cross runway. Okay. So starting from a star-shaped configurations, we can see how the airport has evolved into just 3 runways. Now, let us also look at how runway designations are arrived at. How are runways numbered? Okay. Each runway is identified by a 2-digit number that corresponds to the number that the pilot sees when the pilot comes into land. Okay. The runway number is a whole number which is nearest to the nearest 1/10th of the magnetic azimuth with respect to the runway center line. So you measure the angle of the runway clockwise from the magnetic north, and the number of degrees that you traverse divide by 10 to the nearest integer, and that is the number of the runway. For example, if there is a runway which is oriented at 220 degrees from the north, okay. So if I go from north and if I move clockwise and I come to this particular orientation, when I come into land, then the runway will be called as 220 divided by 10 or runway 22. Okay. Now obviously, because a runway is a straight line, the number at the other end will be different from the number at the one end by 180 degrees, and that is 18. Okay. Now, in case you have multiple runways which are parallel to each other, then you can call them as, if there are for example only 2, you will call them as 03L and 03R. If there are more than one, you can call them as 03L, 03R and 03C as center. Okay. So, for example, this runway at Heathrow is aligned 90 degrees from the north as the pilot comes into land. So, this is called as 09R, and this will be 180 degrees, that means 270, that is 27L, and this is a parallel runway which will be 09L and 27R. L and R are depending on how the pilot sees when they come into land, and this runway is then the runway 0523, inclined at 50 degrees from north and therefore 230 degrees from north in the other end. So, the runways at Heathrow are 09R, 27L, 09L, 27R and 05 and 23. Now, we move to the layout of the airport. We have to understand what are the factors that affect the land area of an airfield. Number, orientation and geometry of runways, parallel runway separations, airport reference codes, location of the landside area, additional area for the future expansion. Generally, around 80 to 95% of the airport area is occupied by the air side and the remaining is occupied by the land side, generally, but there could be differences in this number. Now, there is a very weak correlation between the land area and the amount of traffic actually processed by various airports. There are some airports, for example, there is one in Saudi Arabia which has a very large land area, okay, but it has much lesser traffic. And then there are some airports where the area may be small, but the traffic is very high. Also, there is a very strong correlation between the airport's land area and its potential capacity to handle passenger and aircraft. Okay. Now, there are large differences in air traffic demand at various airports globally. So, one layout is not suitable all over the world. Let us look at the top 60 airports in 2022 from the number of passengers that they have transported. So, we notice that in the top 30 airports, there are 16 airports from the US and only 2 airports, Delhi and Mumbai, from India, and there are 2 airports from Spain. In the 31 to 60 rank, there are 5 airports from the US and now 2 airports from Saudi Arabia, Turkey and Australia, and 1 airport from India, which is Bengaluru. So, in the top 60 airports in the world, India has only 3, Delhi, Mumbai and Bengaluru, but US has 21 out of 60. If you look at the freight carried at the airports, not just the passengers, then you find that there are 9 airports from USA, there are 5 from China, there is 3 from Germany, but none from India in the top 30. Whereas, if you go to 31 to 60 rank, there you find there are 2 airports from India and UAE, there are 3 from China and there are 11 from the US. So, the US has 20 airports from the point of view of freight transportation in the top 60, China has 8 airports, okay? But China did not have many airports in the passenger category, but that number is slowly emerging. Just for getting familiar, let us have a layout of some airports. London Gatwick is an example of an airport with closed parallel runways. So, because they are very near to each other, you can see 26R, 08L, 26L, 08R, very near to each other. So, therefore, we cannot use both of them simultaneously. We can only use one of them at a time. So, Gatwick is classified as a single runway airport, although it has 2 runways because they are closely spaced. And by the way, Gatwick is perhaps the largest throughput of passengers of any airport with single runway operation. Close to 66 aircraft are able to operate per hour from the Gatwick airport. Example of Frankfurt or Main airport, where you have parallel runways which are supported by a 3rd runway. So, you have 1, 2, 3 and then you have one at an inclination here. So, this is the Frankfurt airport, one of the busiest airport in Germany, and you also have a small airport, one runway here. You could also have independent parallel runways with the terminal building in between, and therefore, it allows operations of aircraft simultaneously at both the runways. example is the Munich airport. Now, there are many benefits of independent parallel runways. First of all, you can utilize efficiently the vast area between the independent runways, which otherwise would go a waste. You can have reasonable proximity of passengers and cargo buildings to both runways, assuming that the landside configuration and the apron taxiway systems are very well designed, such as in the case of Munich. You could have better airfield traffic circulation because the aircraft can reach the runway without having to cross the other active runway. And you can have the ability to isolate the airport's landside from the surroundings. This allows you better control on the airport's landside development as well as good ground access to the airports. All these points are applicable, broadly speaking, to the Munich airport. Here is the LaGuardia airport in New York, and here you have a cross runway. Cross runways, as you will learn, are required because of the prevailing wind patterns at an airport, right. Mumbai airport also is an example of a runway, of an airport with cross runways. Then Denver airport has 6 runways which are inclined perpendicular to each other. So, you have 1, 2, 3 and 1, 2, 3. Okay. Perhaps this one and this one can be used independently, but these two may not be used independently because they are very close to each other. Now, you have 8 airports. So, when modification took place, 2 more runways were introduced. So, now Denver has 8 airports apart from the ones which we discussed. Finally, we are going to look at the top airports in India in 2022. From the point of view of number of passengers carried in crores, these are the top 10 airports. The leader is New Delhi with 6.53 crore passengers, followed by Mumbai with 4.39 crore, Bengaluru 3.19 crore, Hyderabad 2.1 crore, Chennai 1.86 crore, very close is Kolkata 1.77 crore, Ahmedabad just beyond 1 crore, Kochi 0.88 crore or 88 lakhs, Goa with the tourism potential 84 lakh passengers and Pune with 80 lakh passengers. So, these are the top 10 airports in India from the passenger throughput. Thank you for your attention.